I thought you were going to ask about electromagnetic pulse.
I'll get to it.
Yeah, I'm not quite sure. I don't know what the predictions are for the electromagnetic layer. The studies that I've looked at don't really consider that. But the presentation I made at the New York Academy of Medicine this year, I did talk about what would happen if the grid went down for a long time and we had enough EMP from weapons that would cause all the nuclear power plants to melt down in the United States. So that could be something we might want to talk about.
Yes, well, let's back into that. I'm well familiar with EMP at a small level. I'm a ham operator. I've got 13 towers up on my property.
Oh, man.
I know that when a storm comes over, I definitely feel the effects of EMP when I get close strikes. However, this is a whole different matter. Now, in order to disable North America, let's say, how many nuclear weapons detonated way up there would it take?
Well, it really wouldn't take very many. I think that's part of the reason why they worry about nations getting any nuclear weapons. If you have a relatively high-yield weapon, it can knock out tens of thousands of square miles worth of anything with a transistor in it. Would melt down basically the control panels at nuclear power plants.
How high, Professor?
Pardon me?
How high?
I think that they would detonate those several hundred miles high. They have, I'm sure they figured all this out. The Russians actually tested. We did a few tests ourselves before they had the atmospheric test ban treaty. They detonated one over the Pacific and it knocked out the power in Honolulu. There was a study that was done about electromagnetic pulse, congressional study, and I got a copy of it, but I don't know if they had a classified version or not, but I was really very disappointed to see that they didn't address what would happen in nuclear power plants. And, so what I did talk, Arnie Gunderson, I bet, he's like really, he's a nuclear engineer that really knows his stuff.
Yes, sir.
I've talked to him about it. He said that, one high-altitude nuclear detonation over the east coast of the United States could knock out like 60 nuclear power plants. And what would happen was that the reactors would melt down, and then also the spent fuel pools that I'd mentioned earlier that have 5 to 10 times more radioactivity, long-lived radioactivity than the cores do, they would boil off. Once the cooling stops, the water heats up and will boil, and when it gets down to the point where the rods are exposed to steam or air, then those rods will rupture, and if they've been removed recently enough from the reactor core, they'll burn.
Right.
And that would release an enormous amount of radioactivity. Just one, nuclear power plants produce a lot more of the long-lived isotopes than nuclear detonations do. For example, one nuclear spent fuel pool has more Cesium-137 in it than all the atmospheric weapons tests combined released, over 1,000 tests. And so, and we have 100 of those pools scattered around the United States. When I did my studies on this, I was looking at there's an exclusion map around the destroyed Chernobyl power plant. There's about 1,100 square miles where they call it a radioactive exclusion zone where people aren't allowed to live. Mm-hmm. And when I was looking at the map one day, I realized that the key for that map was based on how much Cesium-137 was in the soil. And they describe that in terms of becquerels, and I'm not going to give, but what it amounted to was that about 1.2 grams of Cesium-137 contain enough radioactivity to make a square mile uninhabitable for a couple centuries. Wow. An American dime weighs, just 2 or 3 grams. I think it's 2.7 grams. So less than half the weight of a dime of Cesium-137. If you make it into an aerosol or a smoke and spread it over a square mile, you can't live there for 100 years.
My God.
And so the average spent fuel pool in the United States has close to 2,000 pounds of Cesium-137 in each pool. So, and see, cesium is, it's a very volatile element. It's almost like mercury. So around 700 degrees, it actually turns into a gas. And, these rods are hot. The reason they're so radioactive, the radioactivity creates heat. And, if they lose the cooling and they're exposed to air, Once they get up to about 700 degrees, the cesium inside the rod becomes a gas and starts to expand. It'll cause the rod to rupture. And that's why, like at Fukushima, for example, so much cesium was released, because when all those fuel rods, the reactors melted down, it released all the cesium. It went up into the air, and the winds blew it around, and then it rained out. And so there's...
So you're telling me it would take only one large bomb over the East Coast, and all our plants would melt down. And
like there'd be 50 or 60 plants that could melt down just from one bomb.
Might be academic, because at that point we would consider that to be an act of war, and we would be in a nuclear conflict almost instantly, wouldn't we?
I guess so. There's I assume that with a weapon like that they could track it.
Oh yes.
But there's just as an aside too, I'd like to point out to your listeners that a huge solar flare, like the one they had in 1849, I think it was a Carrington
event. Yeah.
If we had anything similar to that today, it would destroy all the really large transformers around the United States that support the grid, and the grid would be down for 6 months to maybe a couple of years.
Sure.
So that's another issue with all these spent fuel pools. It's not nuclear war, but it's something that we ought to worry about. So that's another reason why I'm not really a big fan of nuclear power. I see that in my opinion, they need to. That's something that we need to address immediately. We have to get the spent fuel out of these swimming pools and into at least interim storage.
They want to move it a few miles from me if they can.
I think they should put it in the basement of the White House,
Yeah, well.
Okay, well, maybe some people might resent that, but, it's always out of sight, out of mind.